Assalamu alaikum. My name is Mohammed Faraj Suwaidi. I am an architecture student from the University of Liverpool, School of Architecture, from Qatar. First of all, I wanted to say I'm very grateful for the support that I've also received from Qatar University for awarding the scholarship and supporting my academic endeavors at the University of Liverpool. My architecture background revolves around digital collaboration and creative thinking methods in the academic, creative, and design field. I'm also very excited and grateful to be able to take part in the ASCA 2022 conference, Hybrid Spaces of the Metaverse. The topic of our research is titled The Application of Immersive Technologies in the Early Design Stages in Architecture Education, a systematic review. The authors of this paper include myself, Asterios, Agathides, Adonis Haidar, and Davide Lombardi. The aforementioned authors are also supervising my current research at the University of Liverpool. The research conducted is an initial step towards our exploration and thorough research to develop and explore the potential implementation of immersive tools in architectural education and practice. As a systematic review paper, we focus on the filtration of existing research that involved the use of virtual reality architectural education and potential use of software similar to Gravity, Sketch, and Unity within the virtual environment sector. The filtration of existing research is based on relevant approaches that investigate the use of creative thinking, teaching methodology, and the use of immersive tools. As one of the findings of this paper, we explore the evolution of immersive tools in addition to understanding the advantages and disadvantages of immersive tools throughout the design process and also the implementation and practice. Further findings also lead to proposing a novel teaching methodology that incorporates the use of these tools in the early design stages and design phases of architectural education. One of the main factors that we look into in this research is accessibility and the evolution of these tools, looking at how these tools can allow the user to grasp a one-to-one scale of the space itself that can also be designed and also be able to walk through these areas and further analyze the space from a visualization perspective. As an extension to this, we look into how VR and VE tools can further be elaborated to not only be representation tools, but also begin to allow the user to test out various interactive techniques like 3D sketching and collaborative design methods in the VR and VE environment. By investigating this approach, we look into our main initial research question, which includes the following. How do we develop an educational framework incorporating virtual environments into the early stages of design process in architectural education? And what existing software and hardware can be utilized to achieve, develop, and test this framework practically? So as an initial step to our research, we have been able to include the following phases that include the article research and filtration through databases including Scopus and HumanCAD, screening these selected papers and comparatively analyzing and categorizing each paper and its design methodology approach. Later on, we evaluate each software that has been used in each of these papers through the charts and tables, in addition to understanding how and why these tools were used in each of the research outputs. After filtering down these papers, we were then able to place them in a timeline order to understand the initial approach and how these tools were used back in the 90s and all the way down to the present time. So this is one of the first initial ones, being the VEL lab, which was also known as the Virtual Environments Laboratory. This was one of the initial steps towards incorporating the use of virtual environments in these student cohorts and educational platform. The VEL lab explored the use of a panoramic screen that displays a wide field of view. The display itself was located in the physical room that hosted up to 14 students per session, in addition to allowing the one main user to present a series of pre-built products and to the students via the medium itself. From this paper, we begin to understand that VE tools have always been explored back in the past, looking at how these tools have also advanced today with the software and hardware implementation of VR and AR tools. We begin to understand that these tools have become a lot more accessible and also offer a lot more capability to assist and aid the design process as well. So virtual reality was also initially limited in graphical power and visualization in the early 2000s. Voxel design was an innovative approach that accommodated this limitation by utilizing a building block scheme that provided the user with the ability to create sculptural and structural forms in 3D blank space in VR. This was done by coloring a number of cubes to create different compositions and exploring different ways of creation. DDD rules, I'm not sure if that's the right pronunciation, but it's capital DDD rules, so I say DDD rules, was the name of the software. It was developed in Bauhaus University in Weimar, with the primary incentive to achieve a simple user interface and that supported easy creation in VR environments. In addition to allowing supported easy navigation and sculptural massing in the VR environment, to support spatial understanding of the design at one-to-one scale. So you can look at this also in the present tense, where modern tools like Google Tilt Brush took a very similar approach to DD tools. But instead of being limited to the voxel design, which is very cubic and lower in resolution, users were able to draw in freeform, and in addition to using varied textures and brushes, and also create different compositions and explore them in different techniques. So the example you see above in the second image is an approach that was implemented in a study that takes a very unique / theoretical and practical approach to the architectural design process by involving performative gestures that were then recorded using VR and later explored in architectural form finding. So moving forward from there, Google also developed another software called Google Tilt Brush, which was used by research done by Barzik, which falls under the digital sculpting category, enabling the user to sketch in 3D space as well. So other softwares like Google Blocks and Gravity Sketch follow a very similar framework to Google Tilt Brush, which has similar user demographic in mind for each platform, but it is also made clear when highlighting the toolset and export options that each software offers. And that's where you begin to see the difference in each software and platform. So for this process, Google Blocks was utilized, allowing the user to create simple compositions in 3D space in the VR platform. So the main limitation of the software is primarily the lack of design tools that enable the user to scale and modify faces in the model to achieve higher details in their model and sketches. So more advanced software like Gravity Sketch becomes just as accessible, yet offer a lot more tools compared to Google Blocks that allow the user to create more complex structures and designs. This then leads to us understanding that further approaches in the interactive design can utilize in game engines to create interactive experiences for immersive assessment. So game engines, in this case, is the next step towards this, seeing what people have been able to work with to utilize interactive design. Game engine software has evolved with the intention to appeal to various platforms, including architectural and visualization professions. Game engines like Unity and also Unreal Engine follow a very similar UI design language to 3D softwares as Autodesk 3ds Max, Maya, Blender, etc. All these different softwares have a very common target demographic towards appealing to users and making sure that they're as accessible as possible to these users. This UI similarity allows the user to increase the adoption of the platform due to its familiar UI design. So when we look at all these past research, a number of different papers are also mentioned in the review paper. And a couple of us have been mentioned, and you can look into further detail as well. But from this analysis, we begin to understand that the approach of implementing immersive tools is an ongoing process. We highlight a series of different projects which include different approaches to the design methodology, in addition to understanding how they were able to incorporate the software and introduce it to a series of users. Some of these projects were conducted in an academic and educational platform, which others were conducted in a public platform available to the general public. Projects like the VEL Lab, which is the first image, were one of the initial approaches to incorporating immersive tools as part of the design process. We then delve into the interactive aspect of digital design. The DD tools was later used in regards to this a few years later to explore the concept of voxel sketching in VR. So even though voxel design was initially used because of its graphical limitations at the time, you can kind of compare it now to the present time, where Minecraft, which is also currently a very popular video game that is still popular today, it's a modern video game that embraces voxel design. And because of its simple visual, the modern video game software welcomes a large number of contributors due to the platform popularity, but also the accessibility of the simple voxel design. People don't feel overwhelmed by the design, complications of freeform or sketching. So in regards to accessibility, we find Minecraft to be a very, very popular example for this. This study was conducted by Delaney in 2021. I apologize. The project resulted in a very positive outcome when it came down to addressing inclusive and collaborative interactive design. Because of the accessible nature of the voxel design, users were no longer overwhelmed by complexity that is limited by detail, and it also allowed them to use more of their imagination to explore, create different compositions that can then be further adapted into more complex structures and designs in later stages. This is when the utilization of game engines can then take place. Products that incorporated the use of media station as part of the design process enabled the students to develop immersive experiences that involve interactive input systems that can then be used for spatial analysis and visualization of existing and also ongoing projects. So a recent study utilized the use of game engines alongside 3D modeling software, including Rhinoceros and Grasshopper plugins, to explore AR methods that enable the user to translate and modify their 3D parametric models to fit in specific locations through an AR lens. So VR and VE tools can lead to unique results that can be, oh, I'm not sure what happened there. Can you still see the presentation?
Yes, keep going.
Yes.
So thank you for confirming. So the VR and VE tools can lead to unique results that can vary based on the adopted software and design brief. This aims to utilize software that is accessible and offers a set of advanced tools that can lead to more complex results. Consequently, the software must also offer multiple export options and enable multi-user support for potential collaborative design. Based on the analyzed paper, most of the software used showcased some limitations, including the design tool set, accessibility, and ability to export the model for further development. Little to no research has been done using Gravity Sketch, even though the software showcases great accessible potential to be used as a sketching, modeling, and refinement tool throughout the architectural design process. Gravity Sketch is also a recent tool released in 2017, housing a number of design tools like 3D sketching, edge grab, massing, surface modification, scaling, materiality, alongside others. Extension to Gravity Sketch also enables model import and export in various formats that enable users that enable external software compatibility. Site models in this matter can also be imported to scale to allow the user to sketch at one-to-one scale and explore different form finding techniques in this process. The Unity game engine can then be utilized to assist the development to further elaborate and assess and refine the design. So in conclusion, through the filtered papers, only 4 papers have attempted to integrate VR and AR tools as a substantial tool of the design methodology. Substantial use is defined by the level of VR and AR technology utilization throughout the different stages of the architectural design process. Instead of limiting the tool for visualization purposes only, each of these papers utilize VR and AR using different techniques, some of which enable the students to sketch, explore, alter, and assess their design through the different stages of the project. Other projects also showcased the remote potential for collaborative design and assessment for techniques between peers and the lecturer. Finally, having analyzed the different pedagogic approaches and the integration of VR and AR technologies in the design process, we propose a novel design teaching framework enriching the generative design methodology by integrating the VR and VE tools and explore contextual-based problem-solving techniques similar to the research done by Delaney in 2022. Throughout the design and interactive process, the design workflow can cycle between multiple iterative processes. The proposed framework is an output of the review that has been conducted. The framework itself will then be tested and evaluated in MA Design Studio classes in our future work that aims to provide a conventional methodology for immersive architectural design. Thank you very much.